Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to talk about the word that strikes fear into the heart of every machinist, and that's filing. You don't have to have some kind of magical built-in talent for this. With some simple techniques you can learn how to do it well, and in fact you're even going to have fun, I promise. So let's go. First of all, how do you buy files? Well, you're probably going to want to start with a nice set like this Nicholson set here, and nice is the key there. You absolutely get what you pay for with files, and do not buy cheap files. If you take one lesson out of this video, make it that. Don't buy cheap files. Nicholson is a great brand. I've got some Grobay needle files here, also great. There are many ways you can save money in a hobby machine shop. Many of the discount tools you can buy these days are honestly just fine, but that is not the case for files. So the way you want to buy your files is to go on a reputable tooling supplier, whoever is around in your country, and pay as much as you can stand for them. Go with a reputable brand and pay a lot. It's going to be a little painful up front, but this set of Nicholson files that I've got here is going on 10 years old now. I've used them extensively, pretty much daily in that time, and they are all still as sharp as the day I bought them. These files will outlive me. You're going to want a full-size set of files, and you're also going to want some needle files if you're doing any amount of small work, especially model engineering. Needle files are essential. Then as you need to, you can kind of do infill. You can buy some medium-sized files in between here and there as you find that you need them. Traditionally, files do not come with handles on them. You just get a bare tang, and you need to buy handles such as these wooden ones and install them yourself. You buy the handles in the appropriate size for the tang, you slide the file in there, and then you bang that handle on something like the anvil on your vise, something really solid, and that file will seat down in the handle, and that's all you need to do. Over time it may loosen, and if so, you just bang it down once again and tighten it up. These handles do also come in different sizes. You have to buy the right size for the tang. That can be tricky. These days, the truth is most file sets come with plastic handles already attached. I don't like the plastic handles as much, but unfortunately these wooden handles are getting increasingly hard to find, as are file sets that don't have handles already installed on them. This is why you'll see not all of my files have handles, because I just couldn't find wooden handles the correct size for some of them. You really do want handles on your files. They're much more comfortable to use and you'll get much better control. Files come in many types and they often have slightly snicker-inducing names. I don't know where these names come from, but the names actually don't matter very much because you can see and feel what they're all for. They're essentially just all different coarsenesses of file, from very smooth to slightly coarser all the way up to very, very coarse. Now there are some more subtleties and variations in how they cut that I'll talk about in a second, but in general you don't have to know the names, just look at them and you can see what they do. They also come in different shapes, obviously, for getting into different shaped areas and creating round and square features and so on. They are also typically tapered, which is very useful because this same square file can handle square shapes of many different sizes because of that little taper, and then there's usually a parallel section at the back for more accuracy in making square cuts. Now let's talk maintenance. In order to keep your files sharp, you need to do two important things. One, store them properly. A canvas pouch like you see here is great. The main thing is you need to keep the files from banging into each other. Don't throw them into a drawer and let them roll around because that will dull them. And by the way, same goes for all of your tooling. Don't throw your drills in a drawer or your reamers or your end mills. They'll bang into each other and dull each other very quickly every time you open that drawer. And the second thing is you want to keep them clean. If you buy a set like this, it might come with one of these. This is a file card. It's essentially the devil's hairbrush. It works exactly as you might imagine. You're expected to simply rake it over the file parallel to the cutting edges to clean out the chips and so on. And honestly, I don't use these things because, first of all, they seem really harsh. It seems like it's something that's going to dull the file, and it doesn't seem to be necessary. Here's a file chock full of brass chips, and here's how I clean it. With a chip brush. Just sweep a chip brush back and forth parallel to the cutting edges, and presto, clean file. As long as you do that frequently, a simple $2 chip brush is guaranteed not to damage the file and does a great job. Here it is again on a more coarse file with some steel chips in it. Look at that. Clean as a whistle. Just do that regularly as you use the file and it'll never get gummed up with chips. Some old-timers swear by chalking your file, literally rubbing chalk into it before you use it. I've never found that to be necessary. Maybe it works, I don't know. I just keep it clean with a chip brush. The next step is fixturing. Just like in any machine tool, fixturing for filing is very important. Your setup has to be rigid. Imagine I'm going to clamp this piece in like that, sticking up in space, not much holding on to it. Now, if I go ahead and file this, watch what happens. You hear that horrible noise it's making? That's chatter. Files chatter just like milling cutters do if the work isn't properly supported. And just like on a machine tool, if it's chattering, it's not working very well. It's hard on the file, you're not going to get a good finish, material removal will be inefficient, and so on. So now watch what happens if I lower this down into the vise and clamp down on it well. You hear that? It files silently. And look how much material is coming off of that. All kinds of chips are flying off of this piece, so we're really moving some material. The finish is nice, it's a lot more pleasant on your ears, and the process feels much better. You can feel the difference in a rigid setup when you're filing. Next, you want to make sure the piece is sitting parallel in the fixture. If this top surface is crooked, it's going to be very difficult to file that straight downwards while maintaining the parallelism that's already in that edge. Instead, if I straighten it up and make it parallel to the top of the vise, then when I get my file in there, your body mechanics are such that it's much easier to keep that surface parallel without introducing any additional angle to it. If I exaggerate this for effect, you can really see what I mean. Trying to file that surface parallel, even if I did have room on the vise jaws, is going to be really difficult because your eye and your arms can't tell where flat is. Alright, first skill, let's say I want to take this existing flat edge and I want to move it downwards. The piece is too large in this dimension and I just want to move that surface downwards. Now don't just start filing away, you want to find where that surface is. Rock your file back and forth, left to right and front to back, and you'll feel when it's sitting flat on the existing surface. So once you've found flat, then you can start making cuts and you've sort of trained your arm to where flat needs to be. Then hold the far end of the file with your other hand and start making cuts, moving only in the forward direction and lifting the file for the backstroke. You don't have to push very hard, let the file do the work. Focus on even pressure on the handle and on the tip of that file. When you're first starting out, don't be afraid to do the file rocking motion on every single stroke. Find flat each time. It takes a little bit of extra time, but it will guarantee much better results. Because what you really want to avoid is the surface going crooked either front to back or left to right. Once the surface starts going crooked, it's a lot trickier to correct it. It's much easier to have good technique and keep it flat as you go. Let's talk a little bit more about dragging the file backwards across the work because I know people get fired up about that. It's generally considered poor practice to do that, and the historical reason people give for that is that it dulls the file. Now, I'm not sure if that's true. We've all seen Fireball Tools' video where he ostensibly tested that and found that it was not true. That said, one YouTube video is not science, so I think the truth might be somewhere between the wisdom of the old-timers and the snappily edited YouTube video. But I will say this, dragging the file backwards across the work doesn't help you any, so don't do it, right? It's just wasted effort, and at best it's going to mess up your surface finish. It's also going to mess up your motor control. It's going to mess up your flatness that you've established in your muscle memory by rocking that file back and forth. The bottom line is, at best, it doesn't help you any, so why bother doing it? Now, there are two exceptions to this that I'm going to cover in this video, but in general, cut on the forward stroke, lift on the backstroke. There's one super easy thing you can do to get better at that muscle memory of holding the file flat and parallel to the surface. Grab a Sharpie and glue up that surface. This is what they call a guide coat in Autobody, and it works just as well here. Watch what happens when I start taking my file strokes. I can actually see how flat I was holding that file in both dimensions and whether my pressure was even. So you can see I was a little heavy on the leading edge of the file, and now I'm a little bit light on the far edge of the file, the rocking back and forth there. So as you file, you can make little adjustments until that Sharpie is being eroded evenly all the way across. And after the Sharpie is gone, you can reapply it and go again. Even after you get good at filing, this technique is still great. I still do this all the time if a surface is particularly critical and I want to really make sure I don't mess it up by filing it a little bit crooked. Quick swipe with a Sharpie and there's just no better way to see exactly what that file is doing. Next skill, what if I want to change the angle of that surface a little bit rather than just bringing it straight down from where it is now? Well, once again, Sharpie to the rescue. You can now use it to detect when you're filing at a slight angle. Line up where you think should be an angled cut, and then start making passes, and you'll see if the Sharpie is wearing away first on one end and later on the other end, then you know you're dropping that edge first and you're adding angle to that surface. You should see that Sharpie erode right to left in this case because I'm trying to drop that right edge down a little bit. And again, as you go, feel free to keep adding Sharpie to make sure that you're staying on course. Now you can see I've taken what was a square top edge and I've added a little bit of angle to it. This also works great if you've got a crooked surface and you need to straighten it out. Put a little bit of Sharpie on there and just make sure that you're gently removing the Sharpie in the direction that you want that surface to move downwards. If you need to create a very specific angle on your surface, or you want to move that surface downward to a very specific point, a really powerful tool for that is layout. If you've got layout lines ahead of time that you can file down to, this really helps with your filing accuracy. In this example, I've got kind of a tricky pair of angles that I'd like to file meeting at a peak, so I've laid that out. And again, using my guide code on the top, I can see that I'm now bringing that surface down with the right edge first, parallel to my layout line as I go. So it's a simple matter of filing a little bit at a time and working my way closer and closer to the line. Check it frequently and make sure that you're staying parallel to that layout line, and you can make little adjustments in your forward or aft pressure on the file as needed to make sure you stay parallel to that line. Similarly, when I go to do the other angle, you can see I'm looking for that guide coat to disappear on the left edge first and travel backwards to the right as I create that angle to make sure that I'm staying parallel to the layout line on that side. You can see I'm closing in on my layout lines. The key with this is just to go slowly and check your work often, and you can achieve accurate results quite easily. Up until now, I've been using a coarse file for fast material removal, but just like other machining processes, there are coarse files and smooth files, and the difference is surface finish. That coarse file really sends the chips flying, but the surface that it leaves behind is quite rough. You can feel that with your fingernail. Those are distinctive file marks. So you can use a smooth file then to remove those marks and get a better surface finish. Another method for improving finish is what's called draw filing. This involves holding the file at a 90-degree angle to the work and drawing it towards you. Now this is kind of an exception to the don't run your files backward rule, because this motion right here is not moving that file in the direction of the cutting edges. It's kind of an oblique approach to the way the file is intended to be moved. But this technique is hundreds of years old and is regarded as perfectly valid even by the Never Drag Your Files Mafia. Draw filing is also a great way to give surfaces a nice luster. It gives it kind of a brushed look, and it also removes machining marks, tool marks from the milling cutters, things like that. And it's a great starting point for emery paper and eventual polishing if you want to achieve really spectacular finishes. I know it's not easy to see on camera, but take my word for it, that finish is much better. Let's talk about needle files next. These are specialty tools for getting into very tight spaces and working on very small parts, but otherwise they work the same as the big files. All the rules and regulations are pretty much the same. They come in many, many different shapes, all of which I'm sure have names that are completely different in different countries, but you can, again, just look at them and kind of see what they're for. You don't have to know all the names of them. Just like the big files, they do come in different coarsenesses as well. There are some coarser ones and some finer ones, and they also have different safe edge properties. I'll talk about safe edges in a minute. But otherwise, pretty much just grab a needle file that looks like it has the shape you want and go to town. If I want to put a couple of small V grooves in this edge, I might use a triangular file for this. Now, here comes the other exception to dragging your files. Here you can see me going back and forth. With needle files, this actually is an advantage because it helps you maintain control. Cutting only on a forward stroke with needle files is very difficult because of how small they are. It's quite a bit more difficult to maintain your flatness, your squareness, or whatever specific references you're trying to maintain as you file. If you're someone who still believes this is wrong and evil, well, you do you. I've been doing it this way for 10 years, and these files are all still as sharp as the day I bought them. I find it's worth it even if it is dulling them 1% faster. The additional control is worthwhile. And to be clear, needle filing is all about control. If you're using them, it's not because you have a lot of material to shift, it's because you're trying to create a tiny, perfect detail. So control is the name of the game, and anything you can do to improve your control is going to help you. Furthermore, because they're so small, it's much more difficult to feel where flat is with your body the way that you can with the big files. And again, dragging both directions really does help with that. Now let's talk file edges. The edge of a file also generally has teeth on it for cutting, and it's great for getting into tight spaces. However, there's a lot of times when you don't want that. If I'm filing a notch in the corner of this piece, as I go down, the edge of that file is going to tend to push the surface adjacent to me away from that cutting edge. It's going to remove material on the side of the notch as I go down, which is probably not what you want. Instead, what you want is a safe edge on your file, one edge with no cutting teeth on it. If I file straight downward on this piece with my safe edge on the left, then it's not going to cut the material over there, and I can safely move straight down with my filing and not damage anything dimensionally that's to the left of this file. A lot of needle files have built-in safe edges, such as this Barrett file, and it's even got a safe back on it as well, which is very nice to avoid damaging any surface that you don't want to. In the big files, I have one coarse and one smooth file, both with one safe edge and one regular edge. So I can still get in tight spaces when I need to, but I can flip it over and use the safe edge. Now, for some reason, these big files pretty much never come with one safe edge. They come with teeth on both sides. So when you get some new files, if you don't already have one, you're going to want to create a smooth and a coarse with a safe edge on each. So you're going to go over to your bench grinder and you're going to make a couple of swipes on the edge of that file and grind those teeth off one side. And I know this is going to be painful on brand new files, but it is absolutely worth doing. You don't have to do it to every file, just have a couple that have a safe edge on them. And again, you don't have to do it with the needle files because typically there's many different kinds in the set and many of them have safe edges that'll work for you. Let's get into some specialty filing situations now. First up is lathe filing. This is a very useful technique for chamfering edges, knocking burrs off things that you've cut on the lathe, and so on. You want a fairly smooth file for this. I like a mill bastard file, which is kind of a middle ground, kind of a medium smoothness. You don't want something coarse because the lathe is spinning very quickly, material removal will be very fast, and if you have a coarse file, it's just going to plug up immediately because the file can't keep up with the lathe. There are actually special files for this purpose called lathe files, and the teeth are at a much more oblique angle, much more parallel to the direction of the cut, so that they're less aggressive and they don't plug up as quickly, but honestly I just haven't found that to be necessary. A regular medium coarseness mill bastard file works just fine. The basic technique is very simple. You hold the file by the handle and you move it back and forth, keeping it moving as the work spins so that the file doesn't plug up. Note that both my hands are in front of the plane of the chuck. Never reach over the chuck while doing this. I'm using smooth motions, keep the file moving. I'm controlling the far end of the file with my other hand, and the lathe is running slower than it would for turning so that the file doesn't plug up too quickly. Now this is in a case where a file handle is absolutely not optional. This is a critical safety thing on the lathe. You must have handles on your files. If anything grabs that file, there is the chance of it potentially driving it backwards into your hand, and you don't want that file tang inside your hand. So handles on files, not optional on the lathe. The next specialty technique that's worth knowing about are file guides. These come in many shapes and sizes depending on what you're trying to create. The example shown here are filing buttons, which are little sticks or cylindrical pieces that bolt or clamp or are otherwise attached to the sides of a part and allow you to round a corner or create a radius on a surface. File guides also often take the form of rectangular bars that you clamp on either side of the work, and that gives you a straight edge that you can file down to for creating nice flat surfaces, and also helps you with accuracy because you can line up those filing bars with a layout line that you're trying to hit. Regardless of the shape, file guides all generally work the same way. They're typically hardened tool steel, and as such they're harder than the file. So as you're filing down the work, once the file starts touching the file guide, it stops cutting and you know you're done. And in fact, the file guide prevents you from being able to cut deeper than the guide because it is harder than the file. You might think that that would tend to dull the file, and I suppose theoretically it does, but it's never something that you use often enough to be a concern. as soon as you feel it stop cutting, you stop abusing the file on the file guide, so it's just really not a big deal. File guides also don't have to be hardened. You can feel, even if it's regular steel, when the file starts cutting into the guide, because it's going to get a lot harder to cut, right? If you're cutting a little piece like you see me doing here, if it hits those buttons, and even if those buttons are mild steel, the file is suddenly going to be working a lot harder, and so I know I've reached the file guide surface. Of course, if the guide is unhardened, then over time the file is going to chew it up and it won't be accurate anymore. But if it's something like a rectangular bar, it's easy to just resurface it and keep using it. So hardening is optional, but personally I do like to harden the file guides. I find them more pleasant to use that way. The final technique I'll mention is for filing curves. This is somewhat unintuitive, and it's the number one thing that I see folks new to this do incorrectly, and that's that you want to drop the handle of the file on each stroke. You want the file to describe the reverse curve that you're trying to put onto the work. If you try to make the file follow the curve around the work, what you actually end up doing is creating flat spots. By dropping the handle on each stroke, by reversing the curve on the file, what you get is that the file is only ever touching the work at a tangent point, and so it automatically creates that curve. Essentially, it can't create flat spots because you're never keeping a flat profile on the tangent surface of the curve at any point, if that makes sense. So here I'm demonstrating it with filing buttons, but even without them, this technique works really, really well for creating nice curves. So drop that handle, don't try to follow the curve around with the end of your file. That's really all there is to it. Filing is one of those things that you might be intimidated by because you think you have to have some kind of talent for it, some sort of natural ability, and you really don't. With these basic techniques and a little bit of practice, you will be surprised how much better you get at filing and how quickly it happens. And once you're pretty decent at filing, you'll find yourself going to it very often because it's quicker to set up than the milling machine is, and you can get very close to just as good a results quite quickly, and it's very satisfying. It's nice to have your hands on the work and really feel what you're doing. So I hope this was interesting and helpful for you. Thanks very much to my patrons for making all this happen, and I'll see you next time.